Welcome to Lab 4. Today we're going to talk about using the Transform tab to compute variables, as well as how to calculate z-scores the easy way through the descriptives function. For this lab, you're going to need a few data sets. The first one we're going to use is Lab 4 Data 1. Now you might recognize this data set already because it's the same data set we used during Lab 2. It has two variables, the subject number and the enjoyment. I enjoy learning about statistics. If I go to my data view, I'll see here I have 20 participants, 20 subjects, as well as the enjoyment, how much they enjoy statistics. Now, when I am calculating a z-score, that's what we're going to do today. We want to calculate the z-score for each of these enjoyments. We want to see who has below average enjoyment and who has above average enjoyment. So we might want to first look at the z-score equation, which is z equals x minus mean divided by the standard deviation. So in order to calculate a z-score, I'm going to need the mean and standard deviations. I have the x's. I have each of the individual scores. So to do this, I'm going to have to get my mean and standard deviation for enjoyment. We know how to do that two ways, either through the descriptives frequencies or the descriptive statistics descriptives. For the purpose of this lesson, I'm going to use descriptives. I will click that, open it up, I will get my enjoyment, move it over, make sure that the mean and standard deviation are checked. I don't really care about the min and maximum, and I'll click OK. That will open up my output, and I see here I have this I enjoy learning statistics, the mean of 2.8 and a standard deviation of 1.47. So if I am calculating a z-score, the first thing I want to do is take each score and subtract the mean, 2.80. So I'll go back to my Lab 4 Data 1, and I want a mean, that 2.8, subtracted from each of these scores. I do that by going to the Transform tab to manipulate my data, and this time I'm using the compute function. In here, I'm going to be able to type the name of my new variable, as well as any kind of numerical expression of what math I want to do to create this new variable. So here, I might want to create a difference score. Maybe I'll call it difference of enjoyment. And I'll take my enjoyment and I'll subtract the mean that I just looked up. So I have my individual score minus that 2.8. And I'll click OK. And you'll see here I now have a difference variable that was just created. 1 minus 2.8 is negative 1.8. 4 minus 2.8 is 1.2. I could then go ahead and take this difference score, and I know that I want to divide it by some amount of variability, which is my standard deviation. As a reminder, we can go back to our output and see the standard deviation is 1.47. So I'll go to Transform, Compute, and this time I'm going to type a z-score. I'm going to take my difference of enjoyment, and I'm going to divide it by that 1.47. Oh, that 1.47. Okay. And there I go. I have a z-score. I can look at these and see what are my highest and lowest z-scores. So for instance, here's a really high score. Of course, we see the raw score is 6. Only one person scored a 6, and they have clearly the highest z-score in enjoyment. I can also look at what are my lowest z-scores. I see these people with 1s. Those are a negative 1.22, negative 1.22. So clearly, lower scores have a lower z-score, and higher scores have a higher z-score. We could also check to make sure we did the math correctly by getting the descriptive statistics of this z-score. So we'll go to Analyze, Descriptives, and this time we're going to put in the z enjoyment. I'm going to put both in for purposes. Click OK. And this time I have still that learning statistics, the 2.8, 1.47, as well as the z-scores, which we know the mean and standard deviation of any set of z-scores from the same sample will always be 0 and 1 if we calculated them correctly. This is a good way to check your math. Right. Now that was a lot of work to go through. We had to do multiple times. So a quicker way would be to go to compute. And this time, let's do a second time, but we're going to do it even quicker. I'm going to use my parentheses. I'm going to put the enjoyment score minus that, 2.8 divided by that 1.47. I'm including both steps in the same numerical expression. And remember to use your parentheses to indicate order of operations. PSPP doesn't naturally know order of operations, so you have to do it yourself. And again, I click that and it goes straight to the final answer. Same scores. Cool, right? Well, let me show you one more way to do it that is even easier. We're going to go to Analyze, Descriptive Statistics, and Descriptives. This time, I'm going to look at my enjoyment variables. Still want the mean standard deviation. But I'm going to use a little trick that PSPP offers. And that is to go down to these options and select Save z-scores of selected variables as a new variable. Click OK. And what this does is it automatically creates a new variable with the title z and then the name of your previous variable. It even calls it z-score of I enjoy learning statistics. And it does all of the calculations automatically for you. And you'll see it is even more precise. Here, 2.18, 2.17. That's because this version is using the fully extended mean and standard deviation. It did not round at all. It is using an exact standard deviation. So the results here are going to be even more precise. So, quicker and more precise. Now, as always, whenever we're doing stuff in PSPP, we don't want to just know about the point and click. We also want to know about the syntax. So we can go to the output and we can actually see our syntax. Here I have the descriptives of the mean and standard deviation of enjoyment. We've seen how to do that before. But I also have the computations. The compute function is the one you're going to want to use, and you just write compute and then the equation that you want with the outcome variable on the left side and the calculation on the right side. So here I have compute, the difference of enjoyment equals enjoyment minus 2.8, and then to compute my z-score, the difference in enjoyment divided by 1.47. Here I'm doing again the descriptives with two different variables, and I want to compute. I have the compute of my z enjoyment 2 equals enjoyment minus 2.8 divided by 1.47. The only thing, I love this one because the only thing you need to know is that word compute. Now, if you want to do the z-scores, that quick technique, all you have to do is add in your descriptives this \save. You just have to tell it to save, and PSPP will automatically know that it's going to store this variable with a z in front of it to indicate it is the z-score, the saved z-score of enjoyment variable. To show this off, I've gone ahead and reopened Lab4 Data 1 without any of my variables that I've calculated, but I now have all of that same syntax in this Lab4 Syntax 1, and I'm just going to highlight everything. I'm going to run my selection, and we'll see that I can now go to my output, and I see all of the same calculations. There's those mean standard deviations, my mean standard deviations of enjoyment with the saving. And now when I go to my file, I'll see that all of those same variables were calculated. Excellent. For my next example, I'm going to use Lab4 Data 2. You will recognize this as the same data from Lab 3 last week. We have three variables: our participant number, our time, either 1 or 2 for before and after, and our appreciation of poetry variable. Again, here's the 1 and 2, which I can toggle to before and after, as well as my appreciation scores. And I might want to know, how do each participant, how much appreciation of poetry did they have compared to their peers? So I could get my z-scores by going to Descriptive Statistics, descriptives. I'll move over my appreciation variable, and I'll make sure to click that Save Z-Scores. So let's get rid of the min and maximum. And I'll click OK. Over here, I will see I have my save with the mean and standard deviation. I have my mean of 5, which we knew, and a standard deviation of 2.71. But you'll remember this standard deviation isn't quite right because it includes all 16 participants, which doesn't really work in this situation because 8 of these participants are from time 1 and 8 of these participants are from time 2. So theoretically, they are actually from different distributions. There's 2 totally different time points. And so putting them all to get the z-score of all of them on the same distribution is actually incorrect, is the wrong way of doing this. We want to get the z-scores of just the individuals at time 1 compared to each other, and the z-scores of all the individuals at time 2 compared to each other. So to do that, we're going to have to use some of our skills from Lab 3 by going to Data, Split File, and we're going to organize our group by that time, the before and after. Okay. And this time, if I go to Analyze, Descriptive Statistics, and Descriptives, we will see that by calculating appreciation with saving the z-scores, we now get new z-scores. We're going to get distributions of scores based just on the 1, because it's calculating a special mean and standard deviation for the befores, and based on just the 2s, a special mean and standard deviation for just the 2s. And so here we'll see that that 9 is particularly high compared to the 1. And here we'll see, though, that the 7 is particularly high compared to the 3. So a different range was factored in. And if I go to my Analyze Descriptive Statistics, and I look at the descriptives of this new z variable, which it named strangely because I already had a z appreciation, click OK. And here I will see that my z-score for the after is going to be 0 and 1, and my z-score for before is going to be 0 and 1. All right, now that we've covered how to calculate those z-scores, we're now going to test ourselves with a little bit more computation, that transform compute. Let's imagine that we have a study where we are asking people about their well-being, and we have 2 questions. The first is, I have times when I am very happy. And the second is, I have times when I am very sad. We want to assess well-being based on an average score between these 2 variables. So, if you go ahead and open Lab 4 Data 3, you will find this data. I have 3 variables, the subject number, the happy score, and the sad score. Go to my data view, and I can see that I have those 10 participants, each with their happy and sad variables. Again, I said that I don't want to use these scores independently. I want to get an average amount of well-being based on more than one item. People do this all the time in research, where they want to get maybe 10 or 12 or 40 questions that are all assessing the same idea, and then they merge them together to get a final score. So I could easily just get an average of these 2 variables by going to Transform, Compute, and maybe I will say the average of well-being equals my happy equals, the mean of my happy and my sad. In SPSS, this is the equation. Mean is when you want to calculate an average. You have it in parentheses and separated by commas. So mean, happy, sad. And I click OK. This computes my average score. But as you'll see here, you might notice that these all seem relatively in the middle. They're all around 3. Certainly we have some 3.5s, maybe a 2.5, but they're all pretty average. And that is because of the way these questions are worded. One is worded such that a higher score means that the person is happier, and the other is worded such that a higher score means that they are sad. So if somebody has really high well-being, we'd assume that they would score high on happy and low on sad, just like we have in participant 1 here. But if we average a high and a low, we get a medium. That's not going to work for us. So instead we need to do what's called recoding. We're going to recode one of these variables so that it reverse codes the variable to match the direction we want our data to go in. So let me show you how that'll work. Let's say we want a higher score to indicate that the person has more well-being. So we already have that with happy. That a higher score on happy equals they are more happy, they have higher well-being. But sad is the opposite. We instead have that if somebody has a lower score on sad, they have higher well-being, but if they have a higher score on sad, they have less well-being. So let's reverse it. Let's use that recode into different variables that we had from last week. And this time I'm going to take my sad variable. I'm going to change it into a new variable called sad recode. And I just want to swap all of the values on the range from 1 to 5, or 1 to 6. So I might have my 1 I want to turn into a 6. My 2 I want to turn into a 5. 3 into a 4. A 4 into a 3. A 5 into a 2. And a 6 into a 1. You see how I'm just swapping? I'm reversing it so that now a low score on a sad will actually give me a higher value. And a high score on sad will actually give me a lower value score. Okay. I want to click that change. And now I click, oh, that should be sad recode. Let's edit that. There we go. Click OK. So here I have the inverse. 3, 4, 1, 6. So now I have something I can average. Both this happy and the sad recode, a higher score equals more of that construct. So I'll go to my transform, compute, and this time I'm going to change it to have the mean of happy and my sad recode. And now we see my new average well-being got recalculated as a high score for this person and a low score for this person. So that's it for today. Again, we covered z-scores, how to compute them, also how to use that transform compute. It's important to know that in that compute function, you can pretty much do any mathematical formula you want. So please be creative with it when you are doing your Lab 4 homework assignment, Lab 4 assignment.